So if I want the log of 25, I just use the log button, fourth up on the left. Hit log of 25, and that would be 1.398 approximately. So then I can check, right? So this equation says that 1.398 is the exponent on 10 that will give me a 25, right? So I can just double check, does 10 to the 1.398 give me 25? Do 10 raised to the previous answer. Yep, 25. So we can do base 10s, log base 10s of even weird numbers. And we can do log base E of weird numbers because we have an ln button. So ln of, let's say, e cubed, what is that? 3. Yep, this is a log base E of e cubed, right? ln just means log base E. The bases match, lift off the exponent. So if you can do it in your head, do it in your head. Or if you can't do it in your head, say the ln of 12, right? So E, what power should I raise E to make a 12? That's too hard to do in my head. So I use my ln button, 3 up on the left. ln of 12, 2.485. And again, that's approximate. And double check, okay, is that the power that I should raise E to? Raise E to that number, and yep, we get 12. So we have a couple of bases that we can do any number for. So that's more than we had before, right? Before we were trying to do it all in our heads, and now at least we can do base 10s because that's what our number system is based on. We can do base E's, which is good because a lot of real life exponential growth has base E. All right, so any questions on the last class? That was like a real quick and dirty review. Okay, so let's look at, we're going to look at the laws of logarithms, some properties that are going to be real useful to us. So log base B of 1, do this on the next page, log any base, no matter what that base is, I can evaluate log of 1. Okay, because this is asking me to rewrite 1 as b to the something. So how do I rewrite 1 as b to some power? What should my exponent be? 0, because anything to the 0 is 1. Now my bases match, and I get 0. So log any base of 1 is always 0. How about log base b of b to the x? What's that going to be? It's just x, yep. The input's already rewritten, is already written with b as the base, as b to something, so you just lift off the exponent and get x. All right, c is going to be b to the log base b of x. What do you think that one is? Close. That's a good guess. B to the log base b of x. Let's do it over here. Okay, so this is kind of a lot to look at. It's kind of like information overload. So I want to simplify this expression. So I'm going to say, let y represent log base b of x. Right? So this is a much simpler equation. It just says b to the y. So just letting this whole exponent be y, right? But if y equals log base b to the x, this is a log equation. Could you change it to a different equation that is exponential that says that has the same information? B to the y equals x. So if I replace log base b of x with a y, I get b to the y, which equals x. It's very circular, and that's because these two functions are inverses, which means that when you compose them, you get a round trip. So that's exactly what's happening. I'm plugging x into the log, taking the result and doing b to it, and I get the x back. I get a round trip because these are inverse functions. So b to the log base b of x is x. It's kind of like asking, what's the name of the boy named George? Right? B raised to the power that you raise b to make an x is x. All right, so those three are good starts. And then I have this real interesting one, log base b of x times y. Log base b of x times y. We're saying the rule is that I can take the log base b of x and add that to the log base b of y. So it kind of looks like I'm distributing that log over multiplication, and it's becoming addition. Okay, so, but that's not what I'm doing. This is just a law, and I haven't explained why it's true yet. This is just one property of logarithms. If you're going to take the log of a product, you can take the log of each factor separately and add them. So the reason has to do with the fact that logs and exponents are tied together. And when you multiply like bases, you add the exponents, right? So we have this multiplication, addition, connection. And I'll spell it all out for you exactly where it comes from.
But if we did x times y first and then
yes. Yep. So actually, let's do an example before we prove it, so we can kind of convince ourselves that it's true. So let's say I want to do log base 3 of 3 times 9. Okay. So this should equal log base 3 of 3 plus log base 3 of 9. So if you do the 3 times 9 first, you get 27. So this is log base 3 of 27. And so this is saying 3 to what power will give you a 27? Yeah, 3 times 9 is 27, but okay. Let's change the example a little bit. 9 times 9, log base 3 of 9 plus log base 3 of 9. So this is log base 3 of 81. Okay. Right. Oh, no, 3 times, that's 80. I could have left it the same. I'm sorry. Leave it the same. I know, my fault. Leave it the same. Okay. 27, yeah. What power do you raise 3 to make it 27? 3. 3 times 3 times 3 is 27. Okay, so my exponent here is a 3. Okay, so does that equal log base 3 of 3 which is 1. And log base 3 of 9 is 2. So does 3 equals 1 plus 2? Got it. Okay, so we showed it with a particular example. Turns out this is always true. You can always take the log of a product and break it into 2 separate logs and add them together. And it's because these are exponents, right? When I do 3 log base 3 of 27, I'm saying what exponent should I raise 3 to, right? And here, these are exponents. And when you have like bases, you add exponents. So let's do the formal proof of why this thing is true. Well, maybe we won't, because it's not really important, and I just want you to have some practice. Okay, so this is the main property. There's an analogous property when you do a division. If you want to take log base b of a quotient, you can take the 2 products separately and subtract. So let's do an example. Let's say I want to do log base 2 of 64 divided by 16. 16 go into 64? Yes. Okay, good. So that should equal, according to this property, this should equal log base 2 of 64 minus log base 2 of 16. So if you do the quotient first, 64 over 16, you get 4. So this left side says log base 2 of 4. Does that equal log base 2 of 64 minus log base 2 of 16? Well, what is the log base 2 of 4? 2, because 2 is the power you raise 2 to make a 4. And log base 2 of 64, what should we raise 2 to make a 64? 6. And the log base 2 of 16? 4. 2 equals 6 minus 4? Yes. So it holds in general for any log of a quotient. You can take 2 separate logs and subtract them. Log base 2 of something? You will find that out on Wednesday. Yes, for now you're doing everything in your head. And anything you can't do in your head, you have to solve graphically. All right, last property. If you want to take log base b of x to the p, you can take the exponent off of the x and bring it down in front of the log. Okay, so it seems like kind of crazy, but it's really just a repeated application of that addition one. So this says log base b of x to the p, right? Well, raising x to the p power means multiplying by x over and over and over again. Exponent is just the notation for repeated multiplication. So this says log base b of x times x times x times x. And then apply the product log rule p times, right? So this one. You take the log of a product, you can take each log separately and add them. So I'm just going to apply that repeatedly. So this says log base b of x plus log base b of x plus log base b of x. And I have p of these, right? X times x times x, p times. So how many logs am I adding together here? P. So when you repeatedly add something, what is that? What do we usually do to denote that? Multiplication. And I have p of them, so I have p log base b of x's. Let's do a quick example to show you that it's true. I want to do log base 5 of 125. Well, that's the same thing as log base 5 of 5 cubed. Right. My property says that I should be able to write this as 3 times log base 5 of 5. I should be able to take that exponent and put it down in front. Well, log base 5 of 5 cubed is 3. Just lift off the exponent. And log base 5 of 5 is what? 1. So on the right-hand side of this equation, I have 3 times 1 equal. Right here? From here to here?
What about log base 5?
I rewrote the 125 as a 5 cubed.
Okay.
Yeah. And then I calculated the log base 5 of 125 2 different ways. 1, the traditional way, using the definition of the logarithm. And 2, where I used this new property where I took the 3 and put it down in front. All right, so the rest of the class is to be used for practicing applying these properties. So I'm going to do one with you in each section. And oh, actually, sorry, I have to do these first. Okay, so remember my properties were log base b of xy equals log base b of x plus log base b of y. So if I'm given log base 4 of 2 plus log base 4 of 32, because I'm adding 2 logs that have the same base, I'm being given something that looks like the right-hand side of that property, right? So I can kind of go backwards and rewrite it as a single logarithm where I multiply those 2 inputs. So this is going to be log base 4 of 64, which is what? What do you raise 4 to make 64? 4 times 4, yeah, 3, I think. So for log base 2 of 80 minus log base 2 of 5, I'm being given a subtraction of 2 logs that have the same base. So I can go backwards from the division property, right? So I should be able to write this as a single log where I take the quotient, 80 over 5. So this is log base 2 of 16. And 2 to what power gives you 16? 4. And then log base 2 of 4 cubed, I could do it 2 different ways. I could just use the definition. And I could say, oh, well, 4 cubed is 64. And what do I raise 2 to make 64? 6. So I could do log base 2 of 64 is 6. Or I could use my new property that says I can take that 3 and bring it down in front. 3 times the log base 2 of 4. And what's log base 2 of 4? 2. So this is 3 times 2, which is 6. So you get 6 either way. Kind of make sense? Okay, so these ones we went from expanded to compacted, right? I took a sum and rewrote it as a single logarithm. You can also go from a single logarithm and expand it. So for this first activity, we're going from a single log to expanding. So if I want, I'll do the first one with you. If you want to do log base 2 of 2x, that's a product. So that would be log base 2 of 2 plus log base 2 of x. And log base 2 of 2 we could simplify to what? 1. So this is 1 plus log base 2 of x. So we're expanding. So in part 1 of your activity, you expand. And in part 2, you're going to bring it back together like we did in the examples. So you got 5 minutes. Try to do a couple from each, and then you can finish them on your own time.